Sometimes in these sorts of questions, you have to just try things out and hope things work. But whereas in other times, you can kind of see this path that you can go down. I mean, that's really where you want to be, because then you just need to follow the steps. In this question, I think this is one of these questions because we know we need the area of the shaded region, and that is going to mean integrating underneath the curve to work out these red bits. Which means we're going to need to know this x value, and we can take the whole area and subtract the red parts to work out the shaded area. So that just means, like, we're kind of working backwards. That means we need the x value for q, which means we need to know where the tangent intersects the curve again, because it just touches. That will be a double root, and then it intersects. So I need to find the equation of the tangent, and then I can do that, which means I'm going to need the gradient of the tangent first of all. So that's kind of working backwards to the start. We need to find dy by dx for the curve. Okay, so if I say that again, find dy by dx, get the gradient of the tangent, get the equation of the tangent, find out where it intersects the curve again, knowing that there's a double root already. That will give us the value for x. We can then integrate under the curve, subtract that from the integral of the whole thing, and we're done. Dy by dx is going to be dy by dt, dt by dx. You might go straight to writing dy by dt all over dx by dt. Now, dy, I'm going to do dy by dt first. That's going to be 2t. And dx by dt is equal to 3t squared. So we've got 2t over 3t squared. I can cancel out the t's. I'm going to get t over 3t. Sorry, 2 over 3t. Right, next, we need to know the value of t when x equals 8 and y equals 4. So we can write down that 8 is equal to t cubed and 4 is equal to t squared. So this means that t is going to equal 2. I'd get a plus or minus 2 from the second equation, but I'd simply get one real root from the top one. T is 2. So tangent m equals 2 over 3 times 2. That's just going to be 1/3. Y minus y1 is equal to m x minus x1. Y minus 4 is going to equal 1/3 x minus 8. And we've got ourselves the equation of the tangent. Now we know that it touches at 8,4, well, that's the information we just used, but then we know it's going to intersect again. Now, here's the thing, when they intersect, the x value of the tangent is going to equal the x value of the parametric equation, so we can substitute this into my tangent, and the same goes for y. So when tangent meets curve, t squared minus 4 is equal to 1/3 t cubed minus 8. I don't really want a third hanging around, so I'm going to multiply through. It's going to be 3t squared minus 12 equals t cubed minus 8. And therefore t cubed minus 3t squared plus 4 is equal to 0. We already know that t equals 2 is a root. In fact, it's a double root. And you could either do polynomial division from this, but actually I think we can do it a bit better. It must be that we have t minus 2 squared and then t plus 1. Because the only way you're going to get a plus 4 here, we've already got a plus 4, is if you put in plus 1. So that avoids having to do polynomial division. If you want to do that, you can. You would get a quadratic, which you then have to factorize, but you would ultimately get this. So t equals minus 1 at q. And x is therefore t cubed, which is minus 1. And y is t squared, which is 1. So q is minus 1, 1. All right, quite a lot to do just to get to that point there, but we've managed to work out what q is. So next thing, we know that this height is 1, and this height is 4, and this length is, well, that was minus 1, so this length is 1, this is 8, this is 9. So the equation, the area of the trapezium I'm not going to define it any more than that. It's going to be a half, and then it was 1 plus 4 times 9, I believe. So we remember the parallel sides are here and here, so I add them up and divide that by 2, and I times by the height, which is this 9. And that is going to be 45 over 2. Okay, that's good. Now we need the area under the curve. We're integrating from minus 1 up to 8. Technically y with respect to x. But this changes when we want to integrate parametrically. So we're going to replace, let's just take it, so it's going to be actually t was equal to minus 1. So we're actually going to integrate from minus 1 up to 2. And then it's going to be y. We can use the chain rule. It's going to be dx by dt dt. This is a parametric way of integrating. I've had to change my limits, so then in terms of t, they go with the corresponding x values, and we now are integrating with respect to t. So y was t squared, I believe. Let me just check that. A while ago I dealt with it. And then dx by dt, remember, was 3t squared. So it's 3t to the 4, which is going to be 3/5 t to the 5 if I add 1 to the power and divide by the new power. And then evaluating between minus 1 and 2. So that's going to give me, I can actually take the 3/5 out because I'm timesing, I'm going to substitute my limits in, and I can just, instead of substituting my limits in, timesing each by 3/5, I can just do the 3/5 at the end. So I'm going to get 2 to the 5, and then minus, it's going to be minus 1 to the 5, so it's actually going to be plus 1. 2 to the 5 is, well, 2, 4, 8, 16, 32. So this is going to be 3/5 times 30 times 33. or 99 over 5. So we've got the area of the trapezium, we've got the area under the curve, we're nearly there. The shaded area is going to be 45 over 2 minus 99 over 5. And I want to simplify this. We could either convert these to decimals, or we could make the denominators the same, keep it as a fraction. I might do that. So times top and bottom by 5, get 225 over 10. Times top and bottom by 2, we're going to get 198 over 10. That leaves me with 27 over 10, which is fine, or 2.7. Okay, well done. Good little journey to get the answer using lots of different skills. And we've got the shaded area underneath this curve.